My name is Norman James, and I'm the author of this book. It is a designer's story from the automotive golden age of Firebirds and Moonmen. It is a story of how, through chance and circumstance, I was to live a 13-and-a-half-year odyssey working with the most talented people in General Motors on two of the most exciting projects that anyone could ever dream of. First at GM Styling, under the legendary Harley Earl, to become responsible for design of the Firebird 3, the gas turbine concept car, then to become seriously involved in the early development of manned and unmanned vehicles for lunar exploration, and for hardware that rests on the moon today. Innovation and invention is a common theme in a search to discover the foundation of creativity. The graphic shows highlights from my career, including a formal training in industrial design, a beginning at General Motors Styling and later at GM Defense Research Laboratories, Sunberg Farrar Industrial Design, Rohr Industries for mass transportation, advanced marine craft, and aerospace R&D, all netting 4 design patents and 20 utility patents, 6 still pending. This book, however, is limited to the first 13-and-a-half-year period with General Motors. And these are the only patents from that period. A design patent for the Firebird 3, a utility patent share for the lunar roving vehicle, and my telescope sphere mounting. My early days are covered for background to convey the development of world awareness or a consciousness of what I was seeing. At the left, my uncle's farm is where I was first impressed by the Milky Way in truly black skies and the force of nature's storms. This family group photo was taken shortly after recovering from polio. Left to right are my father, Basil, my mother, Constance, myself at 13, brothers Herb and Pete. Pete is the nearest. Below is a wide view of my hometown, Jamestown, New York, with a population of about 42,000. My father here is skipping stones on Lake Erie, near his brother, Uncle George's restaurant in Westfield, New York. That's the center photo. To the right is a picture of me with my 8-inch reflecting telescope, and below Peter, a block away photographed through that telescope. At the end of World War II, as kids we were impressed at the Movietone News matinees, showing V-2 rocket tests at White Sands, New Mexico, and undertook our own rocket tests. After graduating from high school, and through the great fortune, quote, quote, of having had polio, I was able to accept a New York State Disability Scholarship to study industrial design at Pratt Institute in Brooklyn, New York, and to follow my ambition of becoming an automobile designer. In high school, I studied to become a mechanical engineer. At Pratt, industrial design was part of the art school, which did concern me. These figures show drawing techniques that we were taught. Department head and mentor Alexander Costello also taught us techniques of the old masters that would improve our ability to represent 3D space, very important to industrial designers. On the right is an empathic sketch, which is a technique used to develop design character into a form. And below is a 2D graphic introducing the concept of 3D negative space into sculpture. In a lighter moment, roommate Eric Norton and I ham it up for the camera, mimicking Costello in a color lecture. Below, a car rendering I did for an automobile design class. Above right, roommates Eric and Larry Hagee in between projects. And last, a charcoal study for our 2D design class. Upper left, still at Pratt, a 2-blistered car design, and below a lunar vehicle during an eclipse. James, you're going to Detroit, was what I heard from instructor Vic Canzani, meaning that they had arranged my going to GM Styling as a summer student before my senior year. This would later be extended for a year, and I was assigned to Bob McLean's studio for Firebird 2. I ended up staying at GM, but concurrently attending Pratt the following year, every other Friday and Monday, for academic classes and getting on-the-job credit for my art classes. I graduated in 1956. These photos are of Harley Earl and Firebird 2. On the right, I am on standby waiting for Dave Garraway's pass-by on his Wide Wide World TV celebration of GM's 50th anniversary. On a break with my brothers in Jamestown, we were designing and playing board games. Upper right is a reconstruction of the first sketch I did of Harley Earl's Motorama vision of the Firebird 3 at the Waldorf Astoria, a crowd scene around the yet-to-be-determined Firebird 3. And then the first sketch that came close to what it ended up looking like. That sketch was roughed out using a new string drawing technique with my partner Stefan Hopsberg. The photo I took of taxiing F-104s at an air show had a lightness that I wanted to capture. A Nike surface-to-air missile at the same show influenced the angled fin placements. The string drawing led to the design of this 3D Pratt-style space sketch. When reviewed by Harley Earl, he bought it off almost immediately, saying, "This will be the Firebird 3. The smaller graphic shows how I looked before incorporating Earl's suggestions. A near year-long grind followed, mostly for the clay and mock-ups. Larry Seamy was our head modeler, and he had 3 student modelers working under him. In the second photo is Jim Ewan, lower right, who was assigned to design the instrumentation and joystick controller. Shown is a master plaster being drawn from the plaster cast taken off of the clay model. It was cleaned up and new casts taken to make the fiberglass body parts. Note the centerline structural spine of the chassis, as it was shown in the mock-up. That was retained. This rendering was made as part of the Motorama film production. On the right is the first run of the Firebird 3 at the Tech Center. August 1958, GM Desert Proving Grounds, Mesa, Arizona. The Hollywood film crew is ready for the Motorama production. Director is Hal Moore, and Harry Wolf is the cinematographer. These are miscellaneous photos of the Firebird 3 taken during film breaks. Parked views with all panels open for cooling, and a view from the rear. This high view shot shows body panel distributions, and a front view, hood opened, showing the auxiliary power unit. Emmett Conklin, left, was the main driver of the Firebird 3. Chuck Turns of GM Photographic is here about to take the classic photograph of Harley Earl with the 3 Firebirds. Below is a close-up of the low-beam headlight grille. Upper left, I'm standing beside the bird. Upper right, accessing the electronics compartment ahead of the rear wheel. Electronics, think of relays and switches. Lower left, Harley Earl exiting the Firebird 3, and Stefan Hopsberg is barely visible on the far right. And lower right, Harley Earl in black, talking to Bob McLean. Bob is my boss. Left, an interesting amusement device and experience, riding a crow's nest atop a ballasted fiberglass sphere. Center, assisting a new GM Defense Systems Division study for a lunar sample return proposal to ride on a future Surveyor Soft-Lander moon mission. A year plus later, I was loaned to the Defense Systems Division, now moved to Santa Barbara, for a 5-month period for more work on a lunar sample return proposal. I would also support studies for lunar base building and manned exploration. Ironically, we still did not know what the lunar surface was really like. In June of 1962, my family gathered in Detroit for my wedding to Susan Connor, from a Detroit manufacturing family. From left, Herb, Basil, and Case Tech student Peter, and then Constance and Basil again. After the Firebirds, we investigated many transportation possibilities. Here, the XP-721 for a mass transportation autoline system, riding on right-of-ways or elevated troughs for ram-wing air cushion effects. Not long after this, I asked for and was granted a transfer to the Santa Barbara Group, now restructured as the GM Defense Research Laboratories. By now they had a clear vehicle task to certify a safe landing site for the Apollo, a Surveyor Lunar Roving Vehicle, an SLRV, was proposed to land and perform bearing strength tests on the terrain to assure it was strong enough to drive on. The favored GM maximum mobility vehicle was a 6x6, that is, 6 wheels, 6 of which were driven. It could climb over an obstacle 1.5 times greater than its wheel diameter. Wheels were spring wire baskets covered with a stainless steel mesh so they could operate in a vacuum at extreme plus and minus temperatures. Pneumatic tires were never considered because they were too risky. It wasn't until JPL Ranger spacecraft successfully photographed close-ups of the lunar surface that we finally knew what to design for. Mobile Laboratory, MOLAB. Vehicles were planned for future lunar exploration. NASA funded a proof-of-concept test chassis for MOLAB. By electrically powering the vehicle through an umbilical cord, the test chassis could be reduced to be exactly 1/6 the full vehicle weight, allowing testing of the 1/6 gravity lunar design on Earth. Meanwhile, at home, I had taken the idea of the floating crow's nest and built a boilerplate telescope mounting out of it. It worked surprisingly well, and I decided to convert a 10-inch Cassegrainian I had in progress to that same design. The last figure shows my setup to make a 24-inch spherical master plaster that I would need for tooling. Back at work, NASA and GMDRL were concluding that they should be focusing on supporting Apollo and design a small rover to extend its excursion range from the LEM lander. NASA's main concern was whether it should be a 1- or 2-man vehicle. That is, do you want to risk losing one or both astronauts on the mission? While 6x6s were preferred, we did look at 4x4s. We ran tests of wheel and drive systems, building a squirrel cage dynamometer to test them in a vacuum chamber. In 1967, I completed the sphere-mounted 10-inch Cassegrainian and entered it into competition at Stellafane, the mecca of amateur astronomy in Springfield, Vermont, and winning first place mechanical ingenuity. A few months later, with a job offer from Sundberg Farrar Industrial Design, I left GM to be their rep at Lockheed on the L-1011. It was then that I realized that the design odyssey had ended. 27 years later, I would be invited to a GM reunion celebrating the rovers, pictured here with the Moonmen of my book, Frank Pavlik's, Dr. Greg Becker, and Sam Romano. That evening at our dinner table, I'm sitting with my wife Jenna at the right. Bob Peterson, GM DRL associate and mentor, is standing behind. The building and testing of advanced sphere-mounted telescopes continued in the post-GM aerospace career, summarized in the epilogue. The avocation now is more conceptual, with YouTube documentation of amateur and proposed multi-mirror sphere-mounted observatory systems, the latter becoming the current personal windmills in my life. The brothers are rarely all seen in one photo, as they are themselves avid photographers. The last photo in the book is what is left of the Semo farm, bookending my story. This graphic career summary of patents granted is a product of innovation applied in diversified fields, the so-called thinking outside the box. Most by far were developed at Rohr, Goodrich, UTC Aerospace in R&D advanced design. Advanced refinements of this book may involve updates to the extended career, but in any case they will be enhanced by the body of work now documented on YouTube and at the GM Heritage Center websites.